And if somebody comes up with this circuit and somebody says that look, E and F may be short circuited, that means there is a bridge fault between the two, right, and it is an AND bridge, okay. Then a test could be apply 0 1 1 0, right, and measure the output at the G point, okay. So, measure the output at G. If you see a 0, then you can be sure that that bridge fault does not exist, okay, there is no such fault. But if you find a 1, okay, this is very important. If you find a 1 here, okay, then you conclude that E at F exists, okay. Okay. When we apply and we see G equal to 1, does it mean E ANDed with F exists? Okay. The answer is no. It could be present, right, or it could be some other fault. For example, G stuck at 1 could be present. So, if you find a circuit is faulty, the test cannot tell us what fault is present in the circuit, okay. The testing that we are referring to right now is a go no go test, okay. We apply 0 1 1 0, and if you see a 1 at the output, we throw this circuit away. We say that this is not a good circuit, there is some fault here. A good circuit should have produced a 0, but this one is producing a 1. So, this is a bad circuit, that is all we can say. We cannot conclude that the bridge fault between E at F is there. There may be many reasons why G is showing 1. It could be that G is stuck at 1, or it could be because E is stuck at 0. See, if E is stuck at 0, then also the circuit will produce a 1, right. Similarly, if A is stuck at 1, if A is stuck at 1, E will produce a 0, and as a result G will also produce a 1, okay. So, there can be at least 4 different reasons that we can think of, right, why when you apply 0 1 1 0 the output is 1, okay. So, there is no one reason for a circuit to produce a different output. So, the process of going further to find out what could be the reason, right, that will require more testing. We may have to apply a number of other tests to start eliminating. We can eliminate, let us say, that G stuck at 1 does not exist, right, by applying another test, right. If you have eliminated that, you can now try to eliminate whether E is stuck at 0 and so on, okay. So, a number of tests will be required to pinpoint, right, what is the actual defect, what is the actual defect or fault that is causing the malfunction, okay. Sometimes it is not possible at all, okay. We may not be able to ever show what is the real reason by applying tests and observing, right. So, this whatever I just described is known as diagnosis, where we are trying to find the exact cause of the faulty behavior. If we are able to apply several tests and pin it down to a single fault and say, hey, this is a fault which is causing this behavior, then we have resolved the fault. We call it as resolution. Okay, we have resolved what the fault is, if we can finally come down to a single fault, that is often not possible. We may have maybe 10 different reasons why G is equal to 1. Okay. With a single test, we if I apply 0 1 1 0 and if I find G is 1, then there could be the following reasons. G could be stuck at 1, E could be stuck at 0, A could be stuck at 1, or an and an AND bridge may exist between E and F. Okay. And there could be a few others that we have not thought through. Okay. So, I am able to think of at least 4 possible reasons. A stuck at 0, I am sorry, A stuck at 1, so A stuck at 1, or B E stuck at 0, or G stuck at 1, or E bridged with F. So, this time the resolution is poor. Okay. When I mentioned to you earlier that there is a quality control department, right, whose job is to figure out what exactly is the root cause of failure. Okay. They may not be able to with a single test, they are only able to conclude that one of these 4 reasons is present. Okay. With some more testing, they may be able to eliminate one or more of these uh, causes and reduce it to, let us say, only 2. Okay. Finally, when they really want to figure out what the problem is, they may use other methods. See, for example, they using acids, you can expose the layout of the circuit, photograph it, and then actually see whether the defect is in the bridge fault, etc. Okay. So, those are also techniques that people use at a much later stage. Initially, we want to eliminate as many faults as we can through testing, and then finally, in order to diagnose, okay, we can try to use those methods where we uncap the the package, and then use acids to expose the layout, and look under the microscope and see where exactly the problem could be. Okay. Those are all difficult things to do. So, we should try and see how much we can get done with testing before we go down to diagnosis.